All right, we're going to get into the practicality of some calculus, and I call this section related rates, which is what our whole unit is over. And earlier, you had a lab, and I asked you to think through, if I had that balloon, what was increasing? Well, the volume was increasing, the surface area was increasing, and so was the radius. And the circumference of the outside was increasing, the diameter was increasing, all different sorts of things. And so that's kind of what we're getting into is, can we find over a period of time, that's what our DT is going to be, over a period of time, what is increasing or decreasing with 3D objects. Excuse me. So when we set up a related rate problem, the first thing we need to do is you need to draw a picture and make sure you label everything. And you're going to read the problem. You're going to write find given when with the appropriate information, and I'll give you an example. And you're going to write the relating equation and find the derivative of both sides of the equation with respect to t, because we're talking about growth or decrease over a certain amount of time, or movement, depends on what we're talking about. We're going to substitute in the find given, and then we're going to solve for when. So let's look at an example. Alright, number one, the top of a 20-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So let's first draw a picture. So I have a wall. Here's my wall, and here's my ground. I'll do ground in green. And I have a ladder that's sliding down the wall. And my ladder is sliding down this way, so it's the height is decreasing, and my length is increasing. So you can think about your ladder sliding all the way out. And so it tells me a little bit of information. So let's see here. The length of the ladder is 25 feet. And it's sliding down a vertical wall at a rate of 3 feet per minute. So I'm sliding down. So it's a rate of change. So I have some sort of dt. And so since this is dealing with a vertical axis, that would be dy dt, and it's sliding down, so it's negative. So it'll be -3. And they also give me some other information. They also want me to check where the top of the ladder is 7 feet from the ground. And so I'm trying to find what is the rate of change of the distance between the wall and the bottom. So I'm trying to figure out, I'm looking for what's my rate of change here. They also give me some information that the distance from this point to the ground is 7 feet. Well, if I use my Pythagorean theorem, I can solve for, at this particular moment in time, how far the ladder is, at the base of the ladder is from the wall. And so I can do 7 squared plus x squared is equal to 25 squared. And so this is 49 plus x squared is equal to 625. And so if I subtract 49 from both sides, I get x squared is equal to 576. And I take the square root, and I get x is equal to plus or minus 24. Well, I can't have a negative length, so I'm going to delete this whole minus. So I know that at this particular moment of time, we're talking about 24 feet. Okay. And I kind of look at my, I look at my question, and it's asking me, when the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? And so it's asking me to find what dx dt is. What's the rate of change horizontally? That's dx dt. I'm to find dx dt. They gave me some information. My given they gave me was dy dt is equal to negative 3. They gave me y is equal to 7. We found that x is equal to 24, and our r, that's the length of the ladder, was equal to 25. Excuse me. And so we look for a when. So in our problem, when the top, so notice how it says when the top of the ladder is 7 feet. So that's my when. I'm going to plug in for my y. So when y is equal to 7 and x by association is equal to 24. Okay. And then we're going to have our relating equations. Well, if you notice, I used Pythagorean theorem earlier to solve for my 24 feet, the bottom leg. Well, I'm going to use the same equation. I'm going to use the equation of x squared plus y squared is equal to r squared. However, I can fill certain things in. My r is never going to change. I hope the length of the ladder isn't going to change. That's a little bit bizarre. So what's really changing is the height and the length are changing, but not the ladder itself. And so my r is always going to be constant. So I have x squared plus y squared is equal to 25 squared. And then finally, with all this information, we can go ahead and use it and find our derivative and solve. So my function again was x squared plus y squared is equal to 25 squared. And up to this point we've been talking about taking the derivative with respect to x. Now we're going to take the derivative with respect to t because we're talking about change in time. So before we had dy over dx, well now it's not the bottom is not going to be dx, it's going to be dt in the change of time. And so I'm going to take the derivative for each of these with respect to time. So I have d something, well in this case my variable is x, so I'm going to have 2x, and I'm going to multiply it by my d something. In this case I took the derivative x and do it with respect to time, dt. I'm going to do the same thing with my y. I have 2y, but again I'm not doing it with respect to x, I'm doing it with respect to time. So I have d, in this case, y, dy dt. And that's going to be equal to the derivative 25 squared. I don't really care what the actual value is, I know it's 625, but I just take the derivative. Derivative of any constant is equal to 0. And so I'm going to come back over, I have a lot of variables here. And so what are the variables that I know? Well, I do know that x is equal to 24. I do know that y is equal to 7. So I do know that x is equal to 24, and I do know that y, not 7, is equal to 3. No, you're right. Sorry. It is 7. I'm thinking of the rate and change. Sorry about that. I also know that my rate of change, my dy dt, my dy dt is equal to negative 3. So I'm going to plug these all in, these three values, and solve for dx dt, which is located right here. So I have 2 times 24 plus 2 times 7. Whoops, let me do that again. I did that wrong. Sorry guys. I have 2 times 24 dx dt, that's what we're solving for, sorry about that, plus 2 times 7 times my dy dt. My dy dt is negative 3. and that whole thing is equal to 0. So 2 times 24 is 48 dx dt. That's what I'm solving for. And let's see here, 2 times -3 is -6. -6 plus 7 is -42. So minus 42 is equal to 0. I'm going to move 42 to the other side, so I have 48 dx dt is equal to positive 42. And finally, I'm going to divide both sides by 48. So my rate of change, my dx dt, so it's my change in my, this right here represents my change horizontally over change in time, is equal to, well, if I reduce this, this will be, let's see here, if I take 7s, that will be 6 and 8, and then do the 2s, this will be 3 and 4. So it is moving at a in a positive direction, so it's moving right 3, let's see here, let's get our units, feet per minute. So every every 4 seconds the ladder moves right 3 feet. And there we go. We're going to do a lot of these types of problems in class.